C charts are intended for tracking or monitoring the count. That's what the C is meant to suggest, the count of anything. This particular question kind of highlights how simple P charts are. The average number of defects is 35 per day. What would be the upper and lower limits on a C chart? The count here that's being suggested is counting the number of defects. Notice that with a C chart, there is no issue of sample size or anything like that. It's just day by day or shift by shift if something happened, and if it happened, how many times it happened. Okay, fine. So you want to set up a chart to monitor that. Well, you need the formulas for the upper control limit and the lower control limit that's appropriate to a C chart. The formula for an upper control limit to a C chart is C bar, that's the average count, plus Z. You pick a Z value, oh, I see it's being specified here in this particular question, times the square root of the average count. The lower control limit will then be C bar minus Z times the square root of the average count. Oh, well then for this particular problem, we only actually need, well, for any C chart, you only actually need two parameters. It's set a Z of 3, not a problem. The average number of defects is 35 per day. That is by definition C bar. That's what you were looking for. Okay, so if day by day in the future you're counting defects, the upper control limit on your chart should be 35, right? Plus 3 times the square root of 35. The lower control limit should be same 35 minus 3 times the square root of 35. All right. On my calculator, depending on how many decimal places you want to save for that kind of messy square root of 35, you're talking about, for instance, 35 plus 3 times the square root of 35, 52.7 for the upper control limit, and 17.3 for the lower control limit. You may have some different decimal places depending on how many you kept, but does it really matter? Here's the irony with a C chart. Okay, we found the limits, but let's think about it. What would this chart look like? In this particular situation, oh sure, 52.7 is the most defects you want to see in a day before you get alarmed. 35 is the average number of defects you see in a day, you know, in terms of count before you get alarmed. And then down here, whoops, make that a solid line, 17.3. Oh, well, first off, there's an irony here. That's the lower control limit, right? If we were actually marking defects now, what this is saying is if we had a day in which there were fewer than 17 defects, that's something unusual of concern. Now, defects are bad things. I mean, wouldn't that be a particularly lucky day? Well, anyway, it would be unusual because it's outside the limits. Now, the issue of decimal places. We're talking about marking the count of something day by day. Does it fall outside the limits? Is it usual? Okay, these are the results of the formulas, but you're not ever going to actually observe 17.3 defects. So basically what your chart winds up being is, well, if you see anything up to 52 defects or anything down to 17 defects, that's within the limits. Outside of that, okay, that's a red flag, something's going on. But those are the limits for a C chart.